1,054 teams submitted viable solution papers in the 2013 Moody's Mega Math Challenge. Of those, 55 were distinguished with finalist, semifinalist, or honorable mention prizes, and the top 6 teams were invited to New York to present their papers to a panel of professional mathematician judges.
I think we found with this problem, actually, the majority of it was research and putting together data and sort of being able to visualize what we were trying to do with the data and our overall goal as a whole. But I think a large part of it was the collaboration, the talking, the sort of overall putting it together.
It's kind of affirming to just have somebody recognize your work, and we did work really hard on this problem, and it was a significant time commitment and energy commitment, so it's nice to be able to get recognized for that.
Looking at a greater amount of cities to get a better understanding.
It was a really intense experience. 14 hours really is not that much time, and you just get the problem at like 7 in the morning and you're going like, oh my goodness, like how are we gonna do this? But then to watch it evolve and the kind of possibilities of the different directions, and then seeing your solution all of a sudden appear, that was really worthwhile, I think.
So the process of recycling has been present in the United States for several decades. When looking at the problem, I do think that solutions are attainable because part of our solution was looking at peer effects or how people socially react to recycling. And so there's definitely a possibility of reaching a lot of people to encourage recycling methods if people are educated about the issue in the first place.
An idea here is that if most of my neighbors are recycling, I'll be coerced into doing so as well, and if very few of my neighbors are recycling. This contest really helps understand how important applied mathematics is, because this problem is so important to society today, which is what we clearly saw, because the amount of recyclable materials that are going to end up in landfills is greater than all the landfill capacity in North Carolina already. So just realizing that's something that really hits you, and it makes you realize how much we need to go ahead and tackle these problems right now.
Since the environment is an extremely complex thing, a quantification...
I think we tried to define the best as which way of recycling has the biggest impact on the environment for the lowest amount of money spent. So you're getting sort of the most environmental bang for your buck.
You know, math isn't all about just like memorizing a formula, plug and chug. It's really a dynamic thing that you can change and manipulate to tackle the things that you want to do. And it's changed my outlook in that math isn't pointless at all. It's not numbers floating around. It's real.
Usually in class when you're doing applied math, they give you the numbers and use the numbers to find whatever you're trying to find. However, in this problem, we had to look for the numbers ourselves, look at real data from the government, and then use those numbers and apply them.
I think our group had a very compelling solution to the recycling problem because we had a very strong mathematical section, but at the same time we had really strong analysis and assumptions. So we had a good balance of, I guess, mathematical and non-mathematical components.
I always thought of math as a lot of sort of complicated formulas and complicated theorems and things. But now I've been introduced to a lot of simplification. Instead of making really, really complicated models, how can you make a very simple model fit a complicated problem? And so I thought that was really, really cool.
We found mathematics essential. And that was what was very surprising, that mathematics could be applied very easily to serious problems like recycling.
I think what made our solution stand out to the judges was that ours was mostly simulation and modeling based. We used computer simulations to model whether each recycling method was appropriate for a city rather than just using formulas, for example. And so I think that's what made our solution stand out.
Well, being able to work with my friends on a problem that required a lot of cooperation was definitely a team building exercise. Also a very enlightening one because we shared our skills and what we knew, and we helped each other out when we needed help.
2 inputs, a variety of factors, and 3 outputs.
This challenge did inspire me. It makes me think, wow, there are a lot of problems out there and creative ways to solve them, and it's exciting and inspiring.